the University of Arizona Bio5 Institute, we bring together hundreds of multifaceted experts that include world-class bioscientists, engineers, physicians, and computational researchers. This team science approach is designed to ignite creative solutions to the many complex biological challenges facing our families and communities, and has resulted in disease prevention strategies, promising new therapies, innovative diagnostics and devices, and improved food sustainability.
Hello, welcome to another episode of Science Talks, a conversation hosted by the University of Arizona's Bio5 Institute. My name is Amy Randall Barber.
And I'm Brittany Ullorn.
Some of science's most difficult challenges, including solving world hunger and curing disease, involve more than just traditional fields like plant and cell biology. Data science brings together computational, statistical, and mathematical techniques to expand our knowledge from big data sets collected at the bench, field, or computer. Handling these large data sets can pose a challenge, especially to researchers who might not be familiar with or have the infrastructure to handle big data. Today, we are joined by Nirav Merchant, the co-principal for Cyverse and director of University of Arizona Data Science Institute. Nirav is an expert in developing computational platforms and enabling technologies towards improving research productivity and collaboration for interdisciplinary teams and virtual organizations. Thank you very much for joining us today.
Thank you for having me.
Yeah, we're very excited to speak with you. So I want to start off by taking us back to 2018. So in 2018, you gave a lecture for the College of Science series on humans, data, and machines. And I was watching a bit of the recording, and I noticed that you told the audience that machine-based learning systems were going to soon become their new coworkers. So can you tell us a bit more about this? What exactly is machine learning, for those of us that might not know, and how will we, or how are we currently working alongside of them?
Absolutely. I'm glad you had a chance to look at that talk. It's been a while, but I can definitely say many of the topics we touched in 2018, I can report on progress, and I'll give you some good examples of how machines have started to become our co-workers. But first, let me tell you a little bit about machine learning itself, because people make it more complex than it needs to be. It's actually a rather simple way of looking at what you have embedded in your data. There's a lot of patterns and knowledge that sits in your data. You're looking to discern those patterns and then utilize them to make either predictions or look forward, so that when you find something that doesn't match exactly, but is close to it, you can get a reasonable answer. So the machine learning techniques borrow from statistics, borrow from computer science, math, and then they take these techniques that many of them have been around for decades, but never saw the popular sort of adoption, because in many cases, things like GPUs, which are now very popular thanks to cryptocurrency, or rather I'm sad because it's hard to get them for science, because the cryptocurrency market picks up the GPUs, making it expensive for us to get them. So because of these GPUs and other advanced methods and hardware, people were able to process a lot of data that they could not do before. Hence, with machine learning methods, they're now able to train them. And when you say training for machine learning, you're giving it prior information and saying, build those networks, build those pattern recognition for me, so that when I give you something unknown, you can give me a reasonable answer. It's never perfect, but it's close. So that sort of is a very quick primer of machine learning for you. And keeping in mind that machine learning, much like teaching a child or a human being, from time to time, you need continuing education. You need to correct yourself. So there is no perfect machine learning method. You have to go back and realize it's not performing well for something, train it, give it more data, explain to it, and then it's going to perform better. Now, going back to your original question, I would say the most interesting place where I've seen machine learning methods become my co-worker is I would say in the literally last week, I started noticing it even more closely. There are services that you can give them a lot of text, whether it's a research paper or it's something that is a newspaper article or even a website. They will synthesize all that information and give you a summary. So instead of you reading the whole article, you're now going to get the key, unique content as if that's your summary statement from a lot of data. And these systems were around. So in the 2018 talk, I gave examples of how attorneys were using it for the law firms. But now, you and me, for $6 a month, can get access to that service. So that's where it's become, in a very short time, a highly commoditized system. And I should say, I've been impressed by some of the results that I'm seeing. Again, they're not perfect, but they definitely are better than me skimming through a paper very quickly and missing some of the key pieces. So I think we're getting there.
Yeah, that does sound like a really powerful tool, that example you gave, and how just in a matter of a few years it's become more accessible and affordable, and like you said, it's going to save you time reading all the paper, and it's going to pick up things that you might have missed. So it definitely seems like an asset to your job and to others.
Yeah, and also, to give you even more examples, I like to cook, and I like to collect recipes, and I'm horrible at organizing them, and I find them in different places. And those of you who like to cook or even just collect recipes, uh, when you look at a recipe, you have to convert that into ingredients, and each recipe that you find at a different site is organized differently. Now there is a machine learning based company that takes those, and you can say, this is my recipe from New York Times, this is my recipe from some random website. It actually does machine reading, as in it reads that recipe, it extracts the ingredients, and now it creates a template for you that is consistent regardless from where you got that recipe. So the steps, the protocols now become, so it derives the protocol by reading the recipe. So, there are many examples of how this has become part of our daily life. So now, while I'm cooking, I'm going to have my ML assisted recipe organizer.
That's a really great example. Thank you. So you direct Cybers, which provides life scientists with powerful computational infrastructure to handle huge data sets and complex analysis, and the UA's Data Science Institute, or Data7, which connects UA researchers with institutional expertise and computational resources and infrastructure. Both of these initiatives help researchers to use large data sets and hopefully answer the more complex questions. Can you talk to us about why large data sets hold the keys to understanding life's mysteries, and how do initiatives and resources like Cybers and Data7 play roles in this innovation and discovery?
That's a very good question. Maybe I'll take another step back and then tell you about why we did what we did in Cybers and the Data Science Institute. Over time, it became very evident that we were all becoming experts at producing data, whether we were wearing sensors or the machines that we were using were producing more sequencing data or larger images, much like your phone camera. Every time you have a new version, the size of the image that you're collecting, but also what is being collected by that image is going up, whether it's number of shots that it takes, and then it selects the best shot for showing it to you. We are gathering a lot more data than we ever were, and it's not going to change anytime in the near future. What most people were struggling with was, how do you manage that? And when we say manage data, it just doesn't mean storage. It means from its birth to its demise or its publication or its archival. And to do that in a good way and ensuring that you are a good data steward. You're able to get the most value from that data. If you're just going to collect it and not be able to utilize it, you're just going to be losing money, so to speak, because you've left your ideas on the table. You've left, so the volume of data was what was overwhelming people. And so the first thing we wanted to do was, how do we give our researchers sort of an upper hand and say, you know what, if it's a large collection of data and I have collaborators all over the world, I should be able to do that without having to think of how will I upload this data? How will I share it securely with them? Who can get access to it? If they are in Australia and I'm here, if I make a change, will they be able to see it? Now, when you think of in those terms, you have things like Box or Dropbox. They're very good for documents that are, spreadsheets or small files. But the moment you start thinking of scientific data, that's pretty large. So we were realizing that a lot of our researchers were spending time struggling with this, and because they could not share that, they were confined to whatever they could do in their own labs. And so Cyverse itself tries to break that barrier down and say, all of us are part of a virtual organization. That what I mean is, yes, we are University of Arizona, but to solve a problem, we reach out to a colleague that might be in a different university, in a different city, or it might be somebody across the building. And if the pandemic has taught us anything, is working remotely takes a different kind of skill, but once you get a hang of it, you can very quickly assemble a group of people in multiple time zones and get the work done.
Yeah.
And so Cyverse, even before, like now, 10 plus years ago, subscribed to that mindset. And we said, what can we do to create virtual organizations that could bring people in, that could help solve something, and then they can leave when their task is done. They don't have to be hanging around. And that's how you can get subject matter experts to contribute. If you have everybody join and take a long time to be part of the team and then contribute what they know, it is frustrating for many in a very complex project. So our goal was to make that easy. So fast forward in Cyverse, we built many things, including our data store, which handles petabytes of information, and regular scientists who do not need any sort of major IT help can use their own laptops and do things that nominally would have taken or would not have been possible at all for them. So fast forward that, we took the lessons from there and applied it for the Data Science Institute, where we said, we have a lot of talent on campus that comes from different departments, but our scientists are again struggling to connect with that expertise. How do we put that together in a way such that people are able to quickly solve a problem and then either do proof of concept work that they can go get a bigger grant, a bigger project? And how do we cut across different disciplines? In Cyverse, we were doing a lot that focused on life sciences. Obviously, now our colleagues are from everything from hydrology to astronomy and everything along the way. But the Data Science Institute focused on doing that for our campus specifically, Cyverse being sort of more national and international. The other big piece was, how do we train people? So Cyverse also provides a lot of training, but we realized that many of our faculty colleagues that are working on this when they were postdocs or graduate students, this technologies didn't even exist. The cloud itself was not there. And now they are in their labs and they have spent a lot of time working on something, but they don't have time to pick up some of these new technologies. And their students want to do it, but they also don't have an avenue to do it. So what is it that we can do for our students and faculty such that it's complementing their coursework? All of us have coursework that is so packed. There's no scope for adding yet another class on some of these topics. So how do we bring together people that are going to help us develop the workforce on our campus that is data science aware, that is data science literate, and is going to help everyone. And that's how we started in collaboration with the libraries, Jeff Oliver and Vignesh Subian in systems engineering and biomedical engineering, the data science ambassadors program, where each college provides us with a graduate student who we provide some training and some funding. And then the students collaborate with each other to figure out what is needed in the college and how the Data Science Institute can help bring that training to them. And they are the vehicles of sharing that knowledge within their college and across their college with their peers who are other data science ambassadors. That's now grown further. We also have data science fellows, which are late career sort of PhD students who are working on topics where once they graduate, somebody from other department wants them to work with them on that, so that their own faculty mentors who are super busy can only collaborate with one or two labs. This opens up the door for multiple labs to work together. And finally, under Malaika Oxnam, who's our deputy director, we have the data science educators. We just onboarded 3 of them, and they'll be working on different topics, bringing training. So any given day on campus, you're going to have a lot of option to go learn about good software hygiene, good data hygiene, all the popular data science tools. Because the first step to doing data science right is having a good control on your tools, understanding how to use them, how to organize them, how to collaborate with them, how to organize your data. Once you do that, you can ask higher order questions. But if you don't have your data organized and the first thing you do is to seek a collaborator to work with you, and if they see your data is in some sort of shambles, they'll not be willing to collaborate with you because they know it's an uphill battle. Because if they say, give me data that has this or has that, it's going to take you 3 months to do that, and the moment is lost. So sort of giving you the broad picture of what we do and why we do across Cyverse and the Data Science Institute. And we are also going to launch a new institute, which is the Institute for the Future of Data and Computation, which will even look at these topics more broadly, but with a heavy focus on workforce development for our students.
Oh, wow, that's wonderful. So you've touched every single possible area here at the university, data science wise, as far as education, as far as educating from undergrad all the way through to the workforce. So that's really neat. I did not know any of that. I knew about the center, and that's wonderful. Thank you for sharing.
Yeah, and also along the same lines, we've been very fortunate with the BioFi Keys program, where they're also looking to bring in a lot more data science awareness in it. So as part of having a wonderful organization like BioFi, we are going to work with the team that organizes Keys so that the data science educators will be able to participate and contribute to providing some of the modules and training such that the students have it in a consistent manner. And as a background, a lot of the methods that we use for doing this kind of training come from something called the Software Carpentry, which is an international organization, which we are one of the founding members, where they focus on best practices for scientific computing, but they look at learners of completely full spectrum learning ability. So you may have somebody who is a student in Africa that has a very small laptop and very limited resources, but is very driven to learn. How do you make sure that the learning material is inclusive and allows them to take that? And so we put all our students and the ambassadors through the same software carpentry training so that they know how to build the material, how to communicate, how to share, so that it's a welcoming space to learn. And to that effect, we also have something called Coffee and Code, which happens right here next to the Keating building in BSRL by the coffee shop. And there's a hacky hour, and that happens on Snake and Latte. And I think they also meet at another location. I think they meet at Gentle Ben's. And these are all community organized activities that we participate in. It's not ours to build, it's ours to support. But our goal as an institute is to build that community that others can come and participate and learn, and not feel that this is a U of A thing. So this is a very much something where local startups and other organizations, even companies like Raytheon, their employees show up and ask questions and help and collaborate with each other. So it's a fairly broad mandate for us, but we are very fortunate to have great partners.
Yeah, wonderful. Well, and you mentioned keys, and so that's high school students, working with high school students. So that's even another group of students to educate. Thank you.
Absolutely.
I want to shift a bit to more of a current project that you're working on. So I know we talked about your role at Cyverse and Data 7, but you're also part of a large interdisciplinary group of researchers at the university studying the long-term effects of COVID. So this is part of the NIH Recover Initiative. So I was wondering if you could tell us a bit more about the goals of this project and what your specific role is in that team.
Absolutely. So, as many of you are aware of COVID and COVID symptoms, we are fortunate that most people recover in a way that they're able to conduct their daily life and go back to some level of normalcy. But there are others that over time, they're not able to go back to some level of energy and health that they had before they were infected. And this being so recent, there is no sort of clear uh, path or roadmap where you are diagnosed with something. And again, I am not the person that should be speaking about this. Sai and others who are medical professionals should be, but I'm just sort of giving you the broad view where it's an evolving landscape where we have to take everything from measurements by the wearables, their electronic medical records, their cognitive abilities, and look at what are the indicators, what are the early indicators for people who are suffering from this condition, and how can it be diagnosed and, more importantly, treated so that we can help the person recover, as the name suggests, and come back to better health than where they are today. So as part of that, there are many dimensions of data and data gathering. So Vignesh Subian, who's one of my colleagues who I mentioned earlier, he also is the associate director for our Center for Biomedical Informatics and Biostatistics. He is leading the team that works with multiple sites, much like ours, that NIH has set up, that send the data, but also making sure that that data is harmonized in a correct way so that when we pool this across the whole country and possibly the whole world, there's power and strength in that analysis, and it's not sort of one-off. Similarly, if people are having sensors that they wear, whether it's a Fitbit or an Apple Watch, how do we take the data, but then can we, without sort of leaking their identity or compromising their identity, be able to put these things together such that there is a way to get a good view of what is happening in their lives. And then we can use that to help others that are possibly infected and going down the same path, and we can mitigate that. So hopefully that gives you a view into that project.
Yeah, definitely gave a great overview, and it's clear to see how people from so many different areas of campus and disciplines can kind of work together to meet these common goals and to bring more understanding to long COVID. And hopefully, I guess the goal would be either preventing or just finding solutions to better manage it.
Yeah.
So we like to wrap up with a fun question. We like to think of our researchers as superheroes. If you were a superhero, what would your superpower be?
My superpower would be to make the person relaxed and comfortable when dealing with complexity.
Very, very nice. I would love to be a recipient of your superpower.
Oh, well, thank you again, Nirav, for joining us today. We really enjoyed our conversation with you.
Awesome. Well, thank you for having me, and I look forward to hearing this and others. And thank you for doing this for our campus and the community.
Of course. And we also want to say thank you to our listeners for joining us on another episode of Science Talks. So for more information about the Bio5 Institute, please visit our website at bio5.org. And from all of us at Bio5, we'll see you in the next episode.
Thanks to our listeners for tuning in to another episode of Science Talks. Continue the conversation with us next time as we learn more about the amazing science happening at the University of Arizona's Bio5 Institute.